Hello dear student, I am Mohan. Today in this video we will discuss one more question for subspace. Okay. In previous video we have discussed two questions of subspace. Then in this video we will discuss one more question, and if we get time, then one more question for subspace. Okay. So let's start. The question: which the following set of functions are from R to R is a vector space. Okay. It asking what is a vector space. So we are going to prove with subspace, because we will all know every subspace is a vector space itself. Okay. We all know every subspace imply is a vector space itself. Okay. So using this idea we could solve this question. If because to solve each vector space it will be difficult. Okay. But to show it is subspace or it is not, it will be easy. So using subspace we are going to solve this question. This is a question from CSIRNET. This is a question from CSIRNET December 2016. Okay. This is a question from part B. Okay. And question for 3-1. So first of all we are starting from S1. We are starting from S2, right? S2. S2. What is S2? Limit x those functions which is set such that limit x tends to 3, gx will be 1. Okay. In previous video I have tell you that if it is subspace, then 0 vector theta must belong to this set. Okay. So if S2 is subspace, then it implies 0 vector must belong to this set. Okay. But in case of function, it will be the 0 vector will be 0 function. Okay. In case of function, the 0 vector will be 0 function. So whether this belongs to this set? No, because if it belongs to this set, then its limit will be 1. Okay. If 0 function, this function I am assuming belongs to S2, then it will imply the limit will be 1. Okay, by definition 1. But gx is 0. Okay, so gx is 0, so the limit will be 0. So 0 equal to 1. So it give a contradiction. Okay, so it give a contradiction. It is not possible. So we can say 0 equal to 0 function does not belong to S2. Since 0 function does not exist set, so it is not a vector space. So it is not a space. So S2 is not right. So S2, only S2 is not a vector space. Now S1 and S3 are left. So I am first doing for S1. S1. What is S1? Those functions as the limit x tends to 3, fx will 0. Okay, this is the set of the function, and it is we can say it is subset of R to R. Okay, because R2 is R to R. R2 is not set of all function, those functions from R to R. Okay. You can say in general, suppose S is a non-empty set. Okay, then S to power F. Nothing but collection of those functions. Those function domain is S and codomain is F. In this idea. Okay, so we are going to prove that this is a subspace. Okay, so how we prove that? First of all, we have to check 0 function belongs to or not. Okay, so see if f is equal to 0 function belongs to 0 function, it belongs to for like 0. This is 0 function, right? We can tell it is identical 0. So this function belongs to S1, because if you take this limit x tends to 3fx, then it will imply it is 0, so it will be 0. Okay, so it will imply f equal to 0 function belongs to S1, right? Because those functions belongs to this set limit is 0, so 0 function limit is 0, so 0 function belongs to S1, and since 0 function belongs to S1, so you can say S1 is non-empty. Okay, now first order is done. To prove subspace, we have to check whether 0 function belongs to not. So I have done this. Okay, so now we are going to take two functions. We are going to apply in general definition of function subspace. So I have take two functions. So I am taking two functions f and g. Let f and g two functions belongs to S1. Since f and g two functions belongs to S1, so we can say limit x tends to 3, This will be 0, and limit x tends to 3, gx will be 0. Okay, name it 1. Now take two scalar. Take two scalar alpha and beta belongs to scalar field is R. Then what can you say about this? Limit x tends to 3, alpha f plus beta g x, right? This will be limit x tends to 3 alpha fx plus beta gx, right? So this will be limit tends to 3 alpha fx and limit x tends to 3. This will be beta gx, right? Now alpha is constant, so it will go outside, so it will be limit x tends to 3 fx, and this will be constant, so it outside, so limit x tends to 3, and this will become gx. Okay, so alpha now fx will be 0, so alpha into 0 plus this is beta into 0, so 0 into 0 plus 0 will be 0. Okay, from 1 using 1. So from here you can say limit x tends to 3 alpha f plus beta g, this will be 0, and from here you can say that alpha f plus beta g belongs to S1, and if n is arbitrary, so you can say for all f, g belongs to S1, and for all alpha beta belongs to scalar field R. So from here you can say S1 is a subspace. S1 is a subspace of R2 for R, right? This is subspace, and every subspace is a vector space, so it implies a vector space. So S1 is a vector space. So S1 is a vector space. Now we are going to check S3. Similarly, S3 is quite similar like S1. Okay, you can S3 is the set of all those function H such that whose limit x tends to 3 exist. Okay, so first of all check whether 0 function belongs to or not this set, whether 0 function belongs to this set or not. If 0 is equal to 0, then it will imply 0 function for 0 function is 0 function will be what is equal to 0 for R. Okay, so in this case limit x tends to h will be 0, and this limit will be exist. Okay, and you can say so h equal to 0 function, this belongs to S3. Okay, and since 0 function belongs to this set, so this case is non-empty. Okay, now we take two function. Let two function. We take two function h1 and h2 belongs to S3. Okay, and two scalar. Since h1 and h2 is S3, so we can say limit x tends to 3 h1x. This exists, so I am naming it L1. Okay, this exists L1. Say limit x tends to 3 h2x. This is also exists, so it is L2. Say and name it 1. Now take two scalar alpha beta. If I take two scalar alpha and beta belongs to scalar field R, okay, then limit this limit x tends to 3, the linear combination of h1 and h2. This limit will be alpha beta. What is limit? Calculate this limit. This limit will be alpha into h1x. Okay, I am part of the limit x tends to 3 beta into h2x, right? Because the difference of function, you know, if alpha plus h1 plus beta into h2 like this, then you can break this like alpha h1x plus beta h2x, right? Then I will take limits outside. In this addition alpha h1 beta h2, so I can take limit over this and over this. Okay, so now alpha is a constant, so alpha become outside, beta is a constant, so beta become outside, so this gives alpha into limit x tends to 3 h1x, okay, and beta into limit x tends to 3 h2x. Okay, now limit x tends to 3 h1x will exist. I have named it L1, limit x to 3 is in L2, so this become alpha L1 plus beta L2, so whole thing will be exist. Okay, from 1 it is L1, it is L2, from where? From 1, from 1. So you can say this limit x tends to 3 alpha h1 plus beta h2 x, this limit exists, and since this limit exists, you can say alpha h1 plus beta h2, this belongs to h3, right? For all h1 h2 belongs to h3, and for scalar alpha beta belongs to field R, field scalar. Okay, so h3 become a vector subspace. Okay, from here you can say h3 is a subspace. This is subspace of the vector space R2 R. This is subspace, every subspace is a vector space, so S is a vector space, right? So S is a vector space. So S is a vector space. So S1 and S3 are vector space, but S3 is not. So S1 is vector space. It's correct, but S3 is also vector space, so it's not correct. It's part because it's so mark one answer. Okay. So S1 S3 is vector space, but it's not is correct. All three are not vector because S2 is not vector space. Okay, right? So question correct option are question correct option 3. S1 and S3 are vector space, but S2 is not. Correct option 3. Okay. Also, you can observe that S2 is not close under addition. Okay, this is not close under addition. How? You can check this. You can check this easily. It is a zero vector not belongs to this set, also is not close under addition. S2 those G belongs to this set, such that limit x tends to gx equal to 1. Subset of R2. I told you how it is. So this it's clear that 0 gx is 0 function not belongs to S2. It is clear. Okay, no doubt. Also, these are also the region of imply S2 is not subspace. It is not a subspace. Okay, and also there is also second reason. How? Suppose you choose two functions g1 and g2 from S2. Okay, and it implies limit x tends to 3, g1x will be 1, and limit x tends to 3, g2x is also 1. Okay, now can you tell me what is the limit of limit x to say g1 plus g2 x? What is the limit? It will be limit x tends to 3 g1x plus g2x. Okay, so it will be limit x tends to 3 g1x, limit out to the part center, the or limit will be this, limit or will be this g2x, both will be 1, 1 plus 1, 1 plus 1 will be 2, not equal to 1. So it implies limit x tends to 3 g1 plus g2 x will be 2, not equal to 1. So this implies in g1 plus g2 not belongs to s2, right? So it implies if I take two functions g1 g2, then addition doesn't belongs to s in this set. If I take two functions s1 g1 and g2, it will imply addition, point of addition doesn't belong to set. So s2 never vector space. Okay, because first of all vector is first property v1 is the property. If you take any two vector, then the addition must belongs to this set. It is in this vector function, so the addition must, but it will fail in this case. So S2 never be vector space. Okay, so I have cleared all out regarding this question, and this question correct option are option 3. Okay, this question correct option are option 3. S1 is 3 vectors, but S not. Now we have to solve one more question. I think in a previous video I have left some tasks. Okay, so I am inserting this. In previous video I have left some tasks, so I am inserting this. In the previous video, okay, in previous video I have due to charger problem, so video was disconnected. So I am trying to prove today those the part are left. Okay, I think I have done this. Okay, just A and C proof are left. So I am doing a proof of A and C. See, it's clear that in this question it is not correct. Okay, because we all know union of two subspace V1 and V2 will be a subspace of vectors V over F. You can leave either V1 contain V2 or V2 contain V1, but it's not given. Okay, so only V1 is given, so it's not subspace. Also, it is not subspace because zero vector does not exist set. Okay, theta zero vector cannot belong to this set. Okay, because if theta vector belongs to this set, it will imply theta belongs to theta belongs to V1, but theta does not belongs to V2. But it is not possible. Okay, because since vector is subspace, so it will imply a vector space. In every vector space, null vector always belong, but it implies theta belongs to, if theta belongs to this set, that it implies theta does not belong to V2 is a contradiction. Okay, so it is not possible. So theta vector does not belong to this set, and since theta vector does not belong to this set, means null vector does not belong to this set, so it is not a vector space, not a subspace. So B and correct. And we told you the intersection of any class of subspace, linear sum or subspace. But how we prove this? That intersection of any class of subspace, linear sum subspace, I have not told in the previous video. Okay, so I am going to tell in this video. That part I have tell you now in this video. Okay, so V equal to V1 intersection V2, right? So I am taking two scalar alpha beta from field F and two vector, suppose U and V belongs to V, equal to V1 intersection V2. Now U and V belongs to V1 intersection V2, this implies U belongs to V1 intersection V2, right? And V belongs to also V1 intersection V2. Okay, so from here you can tell U belongs to V1, U belongs to V2. Okay, from here you can tell V belongs to V1, V belongs to V2. Now U belongs to V1 and if V belongs to V1, right? And alpha beta are scalar. Also V1 is a subspace of V over F. Okay, so it will imply from definition alpha U plus beta V. This will imply V1. Okay, now similarly also since U belongs to V2 and V belongs to V2. Okay, and alpha beta belongs to scalar field. Okay, and also V2 is a subspace of vector space V over F. So it will imply alpha U plus beta V. This also belongs to V2. So see, alpha U plus beta V is V1 and this also belongs to V2. So this will imply it belongs to intersection. Okay, so from 1 and 2 it will imply alpha U is plus beta V belongs to V1 intersection V2 V. Okay, and alpha beta are arbitrary. So for alpha beta step and for A V belongs to B, this will happen and imply V equal to V1 intersection V2. This is a coordinate subspace. Okay, so V is a subspace of vector space V over F. Okay, so I prove. So intersection of even proof for any condition of intersection. I prove for 2. Okay, V1 V2. You can prove for V1 V2 and V3. So if I W is subspace, then I have told you intersection of any condition subspace subspace. Okay, the subspace. Now, so it is V1 intersection is subspace. Linear sum. So V1 intersection is subspace. Now linear sum all subspace. How to prove this? You can also prove this. Okay. See, linear sum V1 plus V2. Remember like x plus y. So that x belongs to V1 and y belongs to V2. Okay. So you take two vectors. First of all, if check whether zero vector this belongs to set or not. Okay. See zero vector in this set theta belongs to V1 and theta belongs to V2. Okay, so it implies theta plus theta will be theta belongs to V1 plus V2, right? And V1 plus V2 will be, since theta vector belongs to V1 plus V2, so V1 plus V2 is non-anti-set. Okay, so theta vector belongs to V1 plus V2. Okay, so it is first order equation. Now I have to take two vectors. So I am taking u equal to x1 plus y1 and v equal to vector x2 plus y2 belongs to v1 plus v2. This also belongs to v1 plus v2. Okay, so then I have taken u equal to x1 plus y1 belongs to linear sum v1 plus v2. Since this belongs to linear sum, so x1 belongs to v1 and y1 belongs to v2. So from here you can say x1 belongs to v1 and y1 belongs to v2, and v equal to x2 plus y2. This I have taken v1 from v1 plus v2. So from here you can x2 belongs to v1 and y2 belongs to v2. Okay, now I have taken two scalar. Let alpha beta belongs to f. Okay, then what is the linear combination alpha plus beta b? Can you tell me? So alpha x1 plus y1 beta x2 plus y2. So this gives alpha into x1 plus beta into x2, right? And alpha into y1 plus beta into y2. Now see, alpha beta is scalar. x1 and x2 are both in V. So since v1 is half space, so this vector belongs to, if we name it x3, this vector belongs to v1. Okay, since y and y2 belongs to y1 both belong y and both v2, and alpha beta belongs to scalar, and v2 also half space. So this linear sum, linear combination will be goes to v2 and name it y3. Okay, so this is sum of two member. This is nothing but you will write like this x3 plus y3, and this is the member of v1 plus v2. Okay, where x3 is the this and y3 is this. Okay, so alpha u, I prove alpha u plus beta v, this belongs to linear sum v1 plus v2. For alpha beta is going to scalar, and for u v belongs to vector v1 plus v2. So it will imply linear sum v1 plus v2 is a subspace. Okay, subspace of the vector space v over. Okay, so linear sum is subspace. So I prove linear sum is also subspace. So v1 plus v2 is also subspace. Okay, so this is correct. So in this question, correct option are option NC. So in the next video we will discuss two more questions of subspace. Okay, after that we will go forward and to more important topics. Okay, subspace is the more important topics of CSIRNet from chapter to chapter. So I am taking this chapter first. Okay, so please subscribe my channel and more video will come in upcoming videos. And so thank you.